Imagine a world where everything is the opposite of what we know. Up is down, left is right, and even matter itself has a sinister twin. This isn't science fiction, it's the realm of antimatter. Antimatter is like the mirror image of normal matter. For every particle of matter, there's an antiparticle with the same mass but the opposite charge. Think of an electron, a tiny particle with a negative charge. Its antimatter counterpart, the positron, has the same mass but a positive charge. This mirror-like relationship is what makes antimatter so fascinating and so destructive. It's also what makes it so difficult to study. But what happens when these mirror twins meet? Let's just say it's not a happy reunion. When matter and antimatter come into contact, they annihilate each other in a burst of pure energy. It's like mixing baking soda and vinegar, except instead of a foamy mess, you get a spectacular release of energy. This annihilation is the most efficient energy conversion we know of. It's far more powerful than any nuclear reaction. Imagine the energy of a nuclear bomb. Now multiply that by 1,000,000. That's the kind of power we're talking about. This incredible energy release is what makes antimatter so intriguing for science fiction writers and scientists alike. Could it be the key to unlocking unimaginable power? But before we get ahead of ourselves, let's rewind to the very beginning. According to our current understanding of the Big Bang, equal amounts of matter and antimatter should have been created. This means that for every particle of matter, there should have been an antiparticle of antimatter. So where did all the antimatter go? It's a question that has puzzled physicists for decades. Despite extensive research and numerous experiments, the answer remains elusive. If matter and antimatter annihilate on contact and they were created in equal amounts, then the early universe should have been a very short-lived affair. Theoretically, this annihilation would have resulted in a universe filled with nothing but energy. Everything would have quickly annihilated into a sea of energy, leaving nothing behind to form stars, planets, or even us. The universe as we know it would never have come into existence. Clearly, something tipped the scales in favor of matter. There must have been a slight imbalance, a tiny surplus of matter over antimatter, which allowed our universe to exist. This imbalance, though minuscule, was crucial for the formation of the cosmos. But what caused this imbalance? This is one of the biggest mysteries in modern physics. Scientists have proposed various theories, from differences in the behavior of particles and antiparticles to unknown forces at play in the early universe. Yet, the true cause remains one of the most profound questions we face today. Section 4. A crack in the mirror CP violation. One possible clue lies in a subtle but profound phenomenon known as CP violation. This concept is a cornerstone in the field of particle physics and has intrigued scientists for decades. CP stands for charge conjugation and parity, two fundamental symmetries in physics. Charge conjugation refers to switching a particle with its antiparticle, while parity involves flipping spatial coordinates. In very simple terms, CP violation means that the laws of physics are not perfectly symmetrical. This breaking of symmetry is a rare but significant occurrence in the universe. There are rare instances where matter and antimatter behave slightly differently. These differences, although minute, have profound implications for our understanding of the universe. This tiny asymmetry, discovered experimentally in the 1960s, could be the reason why matter won out over antimatter in the early universe. The discovery was groundbreaking and opened new avenues of research. It's like a crack in the mirror, a subtle imperfection that had enormous consequences. This crack may seem insignificant, but it has shaped the very fabric of our reality. While CP violation offers a tantalizing hint, it's not the whole story. The phenomenon is complex and requires further investigation to fully understand its implications. The amount of CP violation we observe is not enough to explain the matter-antimatter imbalance. This imbalance is one of the greatest mysteries in cosmology and particle physics. There must be something else at play, some unknown physics waiting to be discovered. Scientists continue to search for answers, hoping to uncover the hidden mechanisms that govern our universe. The quest for understanding CP violation and its role in the cosmos is ongoing, and each discovery brings us one step closer to unraveling the mysteries of existence. Section 5. Trapping the elusive antimatter. Studying antimatter is no easy feat. This mysterious substance, which is the mirror opposite of regular matter, presents unique challenges to scientists. Since it annihilates on contact with matter, creating and storing it requires some serious ingenuity. Scientists have to devise complex methods to prevent antimatter from coming into contact with the walls of its container. Enter CERN, the European Organization for Nuclear Research, home to the world's largest and most powerful particle accelerator. This facility is at the forefront of antimatter research. In 1995, CERN made history by creating the first atoms of antihydrogen, the antimatter counterpart of hydrogen. This groundbreaking achievement marked a significant milestone in the field of particle physics. Today, CERN researchers can trap antihydrogen atoms for minutes at a time, allowing them to study their properties in unprecedented detail. This ability to hold antimatter for extended periods is crucial for conducting in-depth experiments. These experiments are shedding light on the fundamental nature of antimatter and its relationship to matter. By understanding these interactions, scientists hope to unlock the secrets of the universe's origins. The ability to trap and study antimatter is a testament to human ingenuity. It showcases the relentless pursuit of knowledge and the innovative spirit that drives scientific discovery. It's a triumph of science and engineering, opening new windows into the universe. As we continue to explore the mysteries of antimatter, we move closer to answering some of the most profound questions about the nature of reality itself.